Hello, and today we're going to look at congruency, particularly with triangles. So, in order for two things to be congruent, it means they have the same measurement. So that has to do with the size and shape of it being the exact same. They're not equal, so to speak, but the measurements are equal. I say that only because if I have a triangle here and I tell you that it's congruent to this triangle here, those aren't the same triangle. One lives in this space and the other one lives in here. But they are congruent, meaning they have the same size, shape, and measurements. So since we already have triangles drawn here, let's talk about a little bit about labeling triangles. So you label triangles based off their vertices, and you go in a certain direction. The direction, honestly, is up to you as long as you go from one to the other, connecting sides. So if I call this A, B, C, then this triangle can be called triangle ABC. It can be called triangle BAC. It can be called triangle BCA, or it can be called triangle CBA, triangle CAB, or ACB. All of those names are going to be the same. You know that there's a triangle with three sides, A, B, and C. Pretty much is what you get from that. Over here, if I call this D, E, and F, then I get the same thing. I can call this D, E, F, and so on and so forth. Now, if I were to say these two triangles are congruent, the question is, what parts are you saying are congruent? For example, let's say we have A is the same as D, B is the same as E, and let's say that C is the same as F. Okay? We can go a step further in saying that CB has the same measurement as EF. AB has the same measurement as DE. And then I can go on and say then lastly that, well, DF must also have the same measurement here as AC. Okay? With all of that drawn now, I could then say that triangle ABC is congruent to triangle DEF. Now, the order in this case actually does matter and is very important because in this point I am saying that A and D are the same angle, B and E are the same angle, and C and F are the same angle. Because this congruency is telling me that, hey, you're going to map this the same way. Also, AB must be the same as DE, BC must be the same as EF, and so on and so forth, because of the order in which I put it. It would not be true for me to say triangle CAB is congruent to triangle DEF, because I'm trying to say then that, oh, well, C and D are the same, which they're not at all. So that's very important. When it comes to maybe doing machining, if someone gave you to tell you certain places to drill holes and those are your vertices of your triangle, for instance, you would want to know to drill it in a certain spot, right? You wouldn't want to drill it in any kind of order out of order. And honestly, in that case, that might not be too bad. You might be able to figure out like, okay, this angle is actually supposed to be this one over here. But in reality, you want to know which parts are the same, right? You don't want to make a mistake and say, oh, okay, these two pieces are supposed to be the same. And then you get to the third side and, okay, because I messed up in the beginning, now the last parts aren't going to be the same anymore. Okay, so that's very important to remember. So that's how you set up congruent triangles. That's how you know if pieces are congruent or not. You match the angles that are congruent when labeling the triangles and saying they're congruent. Also, the sides will automatically be matched as well. Okay, so why the heck does this even matter? Well, I gave it a simple example here when we talk about machining. If I were to drill holes in certain spots, I want to make sure I have it correct to whatever is correlated on my paper or my blueprint. So some other things that are going to be very important here would be with the labeling of those sides or knowing certain measurements. So let me erase this here. I shouldn't leave that up there. We'll erase it. So I'm going to make them a little bigger to see. And I'm also going to change the way this is folded here. So I'm going to have triangle A, B, C, and I'm going to have triangle D, Okay? All right? And I am going to say that, hey, triangle ABC is congruent to triangle DEF. Okay? Well, if I were to tell you that, this side is 3, this side is 4, and this side is 5, then you automatically would know since A to B is 4, then D to E must also be 4. If I were to then tell you that, hey, from B to C is 3, then E to F must also be 3. And from A to C is the same as D to F, so it also must be 5. At first, the triangles may not have looked like they were congruent, or maybe you would have thought, oh, it's supposed to be DFE this time, or something like that. But it turned out we kind of flipped this triangle over and then turned it a little bit. And that's how we got DEF. Okay? Well, we also know something about the angles. So if, for instance, I say that this angle is 37 and this angle here is 53, then what do we know about angle E? What do we know about this angle here? Well, we know that the sum of the angles in a triangle should equal 180 degrees. So we could find out what angle B is, and because B and E would have to be congruent, they would have to be the same measurement, we could then know automatically what E is. Or we could also label the angles in here. So if A is 37, D has to be 37. And if C is 53, then F has to also be 53. Okay? And then we could know that, hey, how do we find the other side? In this case, if we add all the sides together, they should equal 90. So 53 plus 37 equals 90. So that means there would be 90 left over. And so this would be 90 here. This would also be 90 here. What type of triangle is that? That's a right triangle. That's right. It may not look like a right triangle, but it is, because I just sketched this on paper and told you to go in and drill at certain parts. Now you can see that, oh, that's actually supposed to be a 90-degree angle. So that's why it looks like this when I'm starting to actually sketch it out. Or maybe now you can use different principles that you know about right triangles in order to solve this. This is actually a scalene right triangle because none of the sides are equal. None of the angles are equal. And it's a right angle inside the triangle. Okay? So these are principles that you will use for congruency of triangles. If you know that two triangles are congruent and you know the order in which the congruency occurs, if you know things about one, you automatically know something about the other, and vice versa. And you can use this to solve problems, because maybe if you know everything about this one, now you know everything automatically about the second one. That is congruency of triangles. So knowing if two triangles are congruent is very important. If all the angle measurements and side measurements are going to be the same, then those two triangles are congruent. Remember, the order in which you say they're congruent matters, because that angle has to be equivalent and those side measurements have to be equivalent as well. Okay, that's congruency with triangles, and I will see you again soon.